All right, so welcome back. In this video, we're going to talk about how we are going to use trig to find a missing side length. So we want to find value of x. And so in order to find that, I'm going to label for what I know. I know that 14 is my hypotenuse, so that's important. I know that we're going from the angle 48, so we're over here, which makes x my opposite. So I have an opposite in hypotenuse, which means I'm wanting to work with sine. So I'm going to have sine of 48 degrees equals, and then opposite over hypotenuse, so x over 14. Now, when I was teaching this at the high school, I would teach to put this over 1, and then we would cross multiply and solve. So I'd end up with x equals 14 times sine 48. Also, you will save yourself a lot of headache if you always put your constant, that number, in front of your multiplication instead of sine 48 times 14. It just makes it stand out and remind you that it does not go inside your parentheses when you're typing it into the calculator. So from here, to find x, we're just going to type into our calculator. Pull this back up. Oops, forgot that I was there. All right, into our calculator, we are going to type 14 times sine of 48. And again, I like to close my parentheses. And so we end up with, and this tells us to round to the nearest tenth. So we end up with 10.40. So our nearest tenth is 10.4. So we are at approximately 10.4. Approximately 10.4. And that is our side length. I can't put inches or any units on it because we weren't given units to begin with. The same is for any cosine or tangent. You just got to look at the sides given to you and determine whether you have opposite and hypotenuse, or if you have opposite and adjacent, or adjacent and hypotenuse, and then that determines which trig function you use. All right, so our next one is if I'm needing to find an angle. And so I call it basic trig. Our basic trig functions find sides. We're going to use inverse trig functions to find angles. And so basically all that is that we are using our inverse sine, inverse cosine to find our angles. Oh, excuse me, I need a nap evidently. It wants us to find the measure of each angle. So we're going to find all angles. We really only have to use trig to find the first one because we know it's a right triangle. It's right triangle trigonometry. So we've been working with A. We're going to continue with A. So if we continue with A, 24 is our hypotenuse and 12 is our opposite. So if I said opposite. Oh, I probably really do need to go take a nap. 12 is right next to angle A, and so that is our adjacent. So because I have adjacent and hypotenuse, I'm going to be working with cosine. So we want to find cosine of angle A, and we know that that is our adjacent over our hypotenuse. And so then I'm going to put this over 1. And so actually I don't need to put this one over 1. What we're going to do here is to find this angle. I'm going to then just change it from cosine A equals 12 over 24 to cosine inverse, which is cosine to the -1. And then 12 over 24 is the same as 1/2 or 0.5. This is what I'm going to type into my calculator. And I wish that I could easily get to this without having to do all these little clicks. But in order to get to that inverse function on the Canvas calculator, you just got to hit this function, and then I'm going to hit the cosine. On your own handheld calculators, you just hit second and then your function keys. And in here, we're going to type 1 divided by 2. You could also go ahead and type our 12 divided by 24. But what we get is the inverse cosine of 1/2 is 60 degrees. So then we go back to our problem here, and we know that the measure of angle, actually I'm going to write it up in this, the measure of angle A equals 60 degrees. We can also put the fact that the measure of angle B is 90 degrees, so we know that much. Now, to find angle C, you've got two methods. In our geometry, we talked about that the three inside angles of a triangle add up to 180 degrees. Excuse me. So you could use that, or what we call the right triangle corollary. If I have a right triangle, then my two acute angles also have to add up to 90. So that's what I like to use. So I'm going to take 90 minus the 60 that we found, so that the measure of angle C is 30 degrees. I could also do sine of C, or sine inverse of C, and I would find that it was 30 degrees as well. Either one of those ways, subtraction to me is easier than inverse operations, or inverse trig, but inverse trig isn't that hard either. If you need help with that one, just let me know. We are going to talk real quick about angle of elevation and angle of depression. So these two pieces of information, especially like if you end up taking a physics class, you will hear of angle of depression and angle of elevation quite often. And really, the angle of elevation is an angle, I meant to type this out, but I didn't, an angle from the horizontal up to the line of sight. Up to the line of sight. So, angle of elevation, so that's like down here. We've got this horizontal line, which is our height, and then our line of sight, so where we can see. Angle of depression is an angle from the horizontal and it goes down to a line of sight. But really what this means is we have these two parallel horizontal lines. Our angle of elevation is the same as our angle of depression. They're congruent. Why? Because they're alternate interior angles. And that line of sight is our transversal. So what does that mean? That means when we get to a word problem like this one, and we're given the fact that this from this horizontal down is a 20 degree angle of depression, but if we're looking at it from down here and the person in line, right, that is a 20 degree angle of elevation. So it's just your perspective and the way that you're looking at it. All right, so what we're trying to find is we are trying to find how far we are from the base of the ride. And we know that the ride is approximately 150 feet. And I say approximately because, let's be honest, if I'm standing in line, I'm not doing this math anyway, but if I'm standing in line, I am not getting out any type of ruler to try or measuring tape to try to figure out how tall the ride actually is. So we're just going to go with an approximation. I have, from my angle of 20 degrees, that 150 is my opposite side, but this x is my adjacent side. So that means we're going to have to use tangent. We've got a 20-degree angle, right? So tangent of 20 degrees equals, and then my opposite is 150, and my unknown is x. And I'm really glad that this is one of our examples, because this is, we're going to have to do some work when x is on the bottom. So when x is on the bottom, we now have, I'm going to cross multiply. I got x tangent 20 degrees equals 150. And then I've got to solve for x, so I'm going to divide by that tangent 20, divide by tangent 20 degrees. Over here, well, that makes it look like an 8, not a degree. Over here, the tangent 20 degrees goes away, and we're left with just x. And then I'm not going to take the time to go out to the calculator. I already have it all figured out. When I type this into the calculator, 150 divided by tangent 20 degrees, I'm going to get approximately 412.1216. Now, according to the textbook, if it's giving us the problem in whole number tens, and it seems to be rounding to tens, then we need to round to tens, not tenths, but the tens place. So would I have been happy with just a whole number, 412? Yes. What the textbook is saying is, since this is rounded to 150, ours is going to be rounded to that it's approximately 410 feet, or we are approximately 410 feet away from the base. So just make sure that you are reading the Math Excel problems for what to round to very carefully. When in doubt, if it seems like everything is too perfect of numbers and your exact answer doesn't work, try rounding. But that's a little bit cruel to not tell you what to round to. But I didn't make those problems. That's the end. Those are the end of our notes. So see you in class.